Lesson 6.4 is on adding and subtracting polynomials. So in this lesson, we are going to add and subtract polynomials. Just as you can perform operations on numbers, you can perform operations on polynomials. To add or subtract polynomials, you combine like terms. And remember, like terms are terms that have the same variable with the same exponent. So x and 2x are like terms. You could add those together. X plus 2x would give us 3x. Okay? And then same thing with if I have an exponent, if I have 3x squared and 4x squared, those would be like terms. I could add or subtract them. But 4x squared and 5x cubed, x squareds and x cubes cannot be combined because they are not like terms. So we want to keep that in mind with today's lesson. So we're going to start with example 1. We're going to add and subtract monomials. So we are going to look for our like terms first. Like terms are constants or terms with the same variable raised to the same power. So A, I have 15m cubed plus 6m squared plus 2m cubed. I have two terms with m cubed, so those are like terms. 15m cubed and 2m cubed can be added together. So 15m cubed plus 2m cubed, 15 plus 2 gives us 17. So we're going to have 17m cubed. And then I add 6m squared. M cubed and m squared are not like terms, so you can't add them together. In B, I have 3x squared plus 5 minus 7x squared plus 12. 3x squared and minus 7x squared, don't forget subtraction is going to mean that's negative. So 3x squared minus 7x squared will give me negative 4x squared. And this 5 and 12 are like terms, constants are like terms. 5 plus 12 gives me 17. So when I add these terms together, I get negative 4x squared plus 17. In C, I have 0.9 y to the fifth minus 0.4 y to the fifth plus 0.5 x to the fifth and plus y to the fifth. So you'll notice that there are y to the fifth and x to the fifth. Y to the fifth, those will be like terms. The x to the fifth is not. So 0.9 y to the fifth minus 0.4 y to the fifth plus y to the fifth can all be combined. 0.9 y to the fifth minus 0.4 y to the fifth will give us 0.5 y to the fifth, and then plus 1 y to the fifth. So 0.5 y to the fifth plus 1 y to the fifth will give us 1.5 y to the fifth. And then I still have this plus 0.5 x to the fifth. D, I have, these are y's, but it looks like they got cut off. So 2x squared y minus x squared y minus x squared y. Now, the variable piece, x squared y, that is the same for each term. Since the variable piece is the same, I can add and subtract those coefficients. So 2 minus, this is 1, minus 1, 2 minus 1 is 1, and then minus 1 is 0. So this simplifies to 0. Now there are 4 check it out problems for you to do. Go ahead and add and subtract. Pause the video and then resume when you are ready to check your answer. So for A, I have 2s squared plus 3x squared plus s. S squared like terms, so 2 plus 3 gives us 5. So 5s squared, and then I have plus s. B, 4z to the fourth minus 8 plus 16z to the fourth plus 2. 4z to the fourth and 16z to the fourth are like terms. 4 plus 16 is 20, so 20z to the fourth. And then the minus 8 plus 2. Negative 8 plus 2 gives us negative 6, so minus 6. So the simplified polynomial is 20z to the 4th minus 6. For C, I have 2x to the 8th plus 7y to the 8th minus x to the 8th minus y to the 8th. So 2x to the 8th minus 1x to the 8th will give me 1x to the 8th, or just x to the 8th. And then 7y to the 8th minus 1y to the 8th will give me 6y to the 8th. So plus 6y to the 8th. So x to the 8th plus 6y to the 8th. For D, I have 9b cubed c squared plus 5b cubed c squared minus 13b cubed c squared. B cubed c squared, b cubed c squared, b cubed c squared. So these are all like terms. So 9 plus 5 gives me 14 minus 13. 14 minus 13 gives us 1. So 1b cubed c squared, or b cubed c squared. So polynomials can be, let me get my focus, there you go. Polynomials can be added either vertically or horizontally. So far you've been looking at how I've been doing them horizontally. You can align them with like terms, top and bottom, between your two polynomials if you want. So I have my x squareds, my x, my constants. Or horizontally, you can use the associative and commutative property to regroup and combine like terms. So here's my first polynomial, add it to my second, and then you can rewrite it so your x squareds are next to each other, your x's are next to each other, and your constants. And then you can combine your like terms to get the resulting simplified polynomial. So choice is up to you how you want to do it. Both methods work perfectly fine, and you'll get the same answer. So let's go ahead and look at example 2. So in example 2, we're going to be adding polynomials. So you're going to add one polynomial to another. You combine like terms to add them together. So 2x squared minus x plus x squared plus 3x minus 1. So my like terms are 2x squared and x squared. So that's 1x squared. So 2x squared plus 1x squared will give me 3x squared. And then minus x plus 3x. So minus 1x, or negative 1x plus 3x will give me a positive 2x. And then I have plus negative 1. So minus 1. So 3x squared plus 2x minus 1. B, I have negative 2ab plus b plus 2ab plus a. The negative 2ab and the 2ab are like terms, but when you add them together, negative 2 plus 2 gives you 0. B and a are not like terms, so we can't add them together. So b plus a will be our expression simplified. In C, I have 4b to the 5th plus 8b plus 3b to the 5th plus 6b minus 7b to the 5th plus b. 4b to the 5th, 3b to the 5th, and minus 7b to the 5th are all like terms. 4 plus 3 is 7, minus 7 gives you 0. Okay, so 0b to the 5th are just 0 when you combine those like terms. 8b plus 6b plus 1b are all like terms. So 8 plus 6 gives you 14 plus 1, 15. So this simplifies to 15b. And then D, we have 20.2y squared plus 6y plus 5 plus 1.7y squared minus 8. 20.2y squared and 1.7y squared are like terms. So I'm going to have 21 21.9y squared, because 20.2 plus 1.7 gives you 21.9. And then 6y doesn't have a like term, so I'm going to add 6y to keep it in standard form. And then 5 minus 8. 5 minus 8 gives us negative 3, or minus 3. So the simplified expression when I add these polynomials together is 21.9y squared plus 6y minus 3. So now there is a check it out problem for you to do. So go ahead, take a moment, pause the video, try this one on your own, and then resume when you're ready to check your answer. So you have 5a to the a cubed plus 3a squared minus 6a plus 12a squared plus 7a cubed minus 10a. So 5a cubed and 7a cubed are like terms. 5 plus 7 gives us 12, so 12a cubed. And then 3a squared, 12a squared are like terms. 3 plus 12 gives you 15, so plus 15a squared. And then I have this minus, or negative 6a, and minus 10a, or negative 10a. Negative 6 minus 10 gives us negative 16, or minus 16a. So the answer is 12a cubed plus 15a squared minus 16a. So far we've looked at adding, so now we're going to look at subtracting polynomials. To subtract a polynomial, remember that subtracting is the same as adding the opposite. To find the opposite of a polynomial, you must write the opposite of each term in the polynomial. So think about it as distributing a negative to each term. So negative times 2x cubed, negative 2x cubed. Negative times minus 3x, or a negative times a negative is going to become a positive, so positive 3x. And then negative times 7, negative 7, or minus 7. So when we subtract with polynomials, first we're going to distribute that subtraction sign as the opposite, or negative, and then combine our like terms. So for a, we have 2x squared plus 6 minus 4x squared. So 2x squared plus 6 minus 4x squared. So my like terms, x squared, so 2x squared minus 4x squared is going to give me negative 2x squared, and then plus 6. A to the fourth minus 2a minus, in parentheses, 3a to the fourth minus 3a plus 1. So first I'm going to distribute this subtraction, or this negative sign, to each term. So first I'm still going to have a to the fourth minus 2a. I'm going to distribute this negative to 3a to the fourth, so minus 3a to the fourth. Distribute it to the second piece, minus 3a, or negative 3a. A negative times a negative will be a positive, so that's going to be plus 3a. And then to the 1, it's going to be minus 1. Now I can go ahead and combine my like terms. So I have 1a to the fourth minus 3a to the fourth, so that's going to become negative 2a to the fourth, minus 2a plus 3a, negative 2 plus 3 gives me a positive 1, so plus 1a, or plus a. And then I still have this minus 1. So negative 2a to the fourth plus a minus 1. So now we're going to look at part C. So for C, I have 3x squared minus 2x plus 8 minus, in parentheses, x squared minus 4. So I'm going to distribute that negative sign to each piece in this second polynomial. So I'm going to still have 3x squared minus 2x plus 8. And then it's going to be minus x squared. Negative times a negative is a positive, so plus 4. 3x squared and minus x squared are like terms. 3 minus 1 will give me 2, so 2x squared. And then minus 2x does not have any like terms, so it's still going to be minus 2x. And then 8 and 4 are constants, so they're like terms. 8 plus 4 gives me 12, so plus 12. So 2x squared minus 2x plus 12 is the simplified expression. D, I have 11z cubed minus 2z minus, in parentheses, z to the third minus 5. So I'm going to rewrite my first polynomial. So 11z cubed minus 2z, and then I'm going to distribute this negative sign. So negative z cubed, negative times negative is a positive, so plus 5. 11z cubed and minus 1z cubed are like terms. So 11 minus 1 will give me 10. So 10z cubed. And then z is my only term, or negative 2z is the only term with z. So minus 2z and then plus 5. So 10z cubed minus 2z plus 5. There is one check it out problem for you to do. So go ahead and subtract those two polynomials. Pause the video and then resume when you're ready to check your answer. So first I'm going to rewrite my first polynomial. So 2x squared minus 3x squared plus 1. And now I'm going to distribute this negative sign. So negative or minus x squared minus x and minus 1. So now I'm going to go ahead and combine my like terms. So 2x squared minus 3x squared minus 1x squared. 2 minus 3 is negative 1. Minus 1 is going to be negative 2. So negative 2x squared. And then x is the only x here, so minus x. Plus 1 minus 1 gives me 0. So my simplified expression is negative 2x squared minus x. We have one more example, example 4. It's a business application. It says the profits of two different manufacturing plants can be modeled as shown, where x is the number of units produced at each plant. So the eastern plant is negative 0.03x squared plus 25x minus 1,500. The southern plant is negative 0.02x squared plus 21x minus 1,700. So write a polynomial that represents the difference of the profits at the eastern plant and the profits at the southern plant. So we are going to subtract the eastern and the southern plant. So the eastern plant minus the southern plant. So we distribute that negative sign to each piece inside the term. So we're going to keep our first polynomial, negative 0.03x squared plus 25x minus 1,500. Negative times a negative is a positive. So positive 0.02x squared. A negative times a positive will be negative. So minus 21x. Negative times a negative is a positive, so a positive 1,700. So now I'm going to add negative 0.03 plus 0.02 gives you negative 0.01 x squared. And then 25 plus negative 21 will give you 4x. Negative 1,500 plus 1,700 will give you 200. So when you combine them by subtracting, you get the polynomial negative 0.01 x squared plus 4x plus 200. There is a check it out problem at the bottom. It says use the information above to write a polynomial that represents the total profits from both plants. So go ahead, take a moment, pause the video, try this one on your own, and then resume when you're ready to check your answer. So finding the total profits, that means we need to add. So we're going to add the eastern and the southern together. So I'm going to use the vertical method since they use that in this example, just so you can see that as well. So far I've been adding and subtracting the polynomials horizontally. So eastern was negative 0.03 x squared plus 25x minus 1,500. And Southern is negative 0.02 x squared plus 21x minus 1,700. So I'm going to add these two polynomials together. So negative 0.03 plus negative 0.02 is going to give me negative 0.05 x squared. And then 25x plus 21x will give you 46x, so plus 46x. And then negative 1,500 plus negative 1,700 will give us negative 3,200. So minus 3,200. So when we add those together, we get negative 0.05 x squared plus 46x minus 3,200 for our final answer.